All right, we are starting rigid transformations. All right, after this, you should be able to describe and perform transformations of figures in the coordinate plane. You should have figured out from the explore activity that transformations are some kind of movement of a shape. This is the notes page you should have grabbed from the front table, and make sure you glue it into your notebook. All right, a transformation is an operation that maps an original figure called a pre-image to a new figure called an image. A transformation can change the size, position, or the orientation of a figure. We are learning about rigid transformation. That means that our size today is not going to change. The first one we're talking about is reflection. The reflection is the flip. It's over a line called a line of reflection. Each point in its image are the same distance from the line of reflection. Some possible lines of reflection that we're going to be seeing are the x-axis and the y-axis. We can also have vertical or horizontal lines in the form of y equals a number and x equals a number. Remember, this can be y equals 3, and this would be a horizontal line. We can also have diagonal lines in the form of y equals x and y equals negative x. Remember, these would be at the origin since there's no y-intercept, and our slope would be 1 or negative 1. All right, let's look at this first example of our reflection. If I can get my triangle to come up. We have triangle ABC. Make sure whenever you are plotting these points, you're plotting the correct x and y. When we're looking at our coordinates, our x comes first and then our y, and our x-axis is along here, our y-axis is here. Our line of reflection here is our x-axis. So remember what it said, that our points are the same distance from the line of reflection. So we see point C is 1 point from our line of reflection. So my new C is going to be 1 point from our line of reflection. Same thing with B. It is 1, 2, 3, 4, 5, 6, 7 points. 2, 3, 4, 5, 6, 7. You see that I'm only changing I'm only going below the x-axis. I'm not changing my actual axis. My coordinates calculated. Let's look at my points that A now is at 1, 2, 3, 4, negative 5, negative 2. It should be negative. Yeah, sorry. I'll note it was a negative 4, negative 2. My B is at 4, negative 7. My C is at 5. You can see, based on just looking at the points, that our x's actually stayed the same. That's because we were reflecting over the x-axis. My y's are the only ones that changed. All right, let's look at one more example. We have this rectangle here, PQRS, with vertices here, and we are reflecting it over the y-axis this time. And my y is this, so I am reflecting over. So my P is 1 point from the line of reflection. Q is 2, and my R is 8, and my S is 7. Make sure your new image, when you're labeling your points, they have a little apostrophe. That's how we note that they are the actual image. I can see that my rectangle does not hit my points properly, but that's okay. Let's look at where our points are. P was at negative 1, 2, Q is at negative 2, 5, R is at negative 8, 3, and S is at negative 7, 0. You can see this time that our x's actually changed. They went negative, and our y's are the ones that stayed the same. That's because we were reflecting over the y-axis. All right, these examples are going to be on videos on the hub if you need extra examples. Next, we have a translation. This is where we're moving it vertically and or horizontally. We're sliding it. These are the easiest transformations. We have a symbolic form for that. We say xy goes to x plus h, y plus k. Our h represents our horizontal shift. So this is how I'm moving to the right or to the left. And my k represents my vertical shift. This is how many I'm moving up and down. If my h is positive, I'm moving to the right. If my h is negative, I'm moving to the left. My k is positive, I'm moving up. If my k is negative, I am moving down. All right, this rectangle QRST, remember to label your points. And we're following this rule right here. It says x plus 5, y plus 7. They're both positive. My x plus 5 means that I'm moving to the right 5. My y plus 7 means I'm moving up 7. So we're going to take it point by point and moving right 5 and then up 7. Moving on, move over 5. Again, my rectangle board needs to be calibrated again. All right, so you can see how we moved our rectangle. Let's look at where our points are. My Q looks like it is at -1, 6. Well, let's look at that in relation to our first Q, our pre-image Q, and the movements that we made. Our pre-image Q was -6, 1. We moved plus 5 on the x and plus 7 on my y. If I take -6 plus 5, I get -1. If I take 1 plus 7, oh, it's a -1. Sorry. I take -1 plus 7, that is a 6. It's not a coincidence that this is what our point ends up being. So you can actually just take your rule and apply it to your points before or after you are plotting. So this is x2, 8, x2, and 3, 0. All right, let's look at this example triangle CDE. We are going to move it by the rule x minus 3, y plus 8. Since my x is minus, I'm moving to the left this time. My y is again positive, so I'm moving up. So let's see point by point what that looks like. All right, you can see whenever I move to the left 3 and up 8, this is where my triangle ends up. Let's look at where our points are. All right, our points now are -1, 7, 4, 4, and 1, 2. Again, you could look at point C, subtract 3 from your x value, and add 8 to your y value and get the same points. All right, this example is again in the notes and on the hub. Let's look at this one though. We need to actually write the rule describing this translation. So remember, it starts out with xy goes to y goes to. First, we look at our x's. How many did it move over? Did it move to the right or left? Our pre-image is labeled just DEF, no apostrophes over my points. So this is my pre-image. And we'll do this image. So let's see. Looks like it moved to the right. Let's look at point B. How many did it move to the right? 1, 2, 3, 4, 5, 6, 7. So my x is plus 7. My y, did it move up or down? It looks like it moved up. So let's see how many up. 1, 2, 3, 4. So that is a plus 4. One more example of writing the rule. Again, you got to start off with x, y. X, y goes to, let's look at our x's first. My MNPO dot R does not have the apostrophes. Looks like my x is moving to the left, so this time it's going to be a minus. So let's look at this p. We got 1, 2, 3, 4. It moves over to the left 4. Oh. 4, comma, what does my y do? It looks like my y moves up. Count those spaces, it moves up 2. All you have to do to write the rule is look at one of the points. You don't have to look at them all. Just make sure you're going from the pre-image to the image and not vice versa. All right, let's do rotations real quick. We have rotations are a turn around a fixed center called the center rotation. And it rotates at a specific angle in a specific direction. That means most of them are going to be 90, 180, and 270, clockwise or counterclockwise. So ignore the purple for just a second. We're looking first at this counterclockwise rules. Okay, so if we are rotating 90 degrees counterclockwise, this is going to be a rule. We're going to take our x and y and we're going to flip their numbers. And we're going to make our y negative, and we're going to have negative y x. For counterclockwise rotating 180, it's going to be negative x negative y. And if we are rotating 270, it's going to be y minus x. On this side in purple, this is my clockwise rules. If we are rotating 90 degrees, we are flipping it, but we're making the x negative this time. So it'll be y negative x. My 180 rule actually stays the same because it doesn't matter which way we're going. We're going to end up in the same spot. And 270 is negative y x. Makes more sense with an example. All right, let's look at our triangle ABC. Make sure you plot points. This is asking us to counterclockwise rotate 90 degrees. So what was our rule for counterclockwise 90 degrees? It was negative y x. So that means I'm going to take each of my points. This is point A, and I'm going to flip my x and my y, and then I'm going to make that first number negative. So my y is 7, so that turns into a negative 7. My x is 2. I'm going to do this for all 3 points. 6, 5. All right, so you can see what my points are. These will be what it's asking for down here. These will be our actual points of our image. So once you plot them, you can see the rotation of the triangle. All right, so you can see that my triangle is rotated. These are the hardest transformations to see on paper. So if you are struggling with this, then come get some shapes from me, okay? Let's do one more example. Okay, we have square PQRS. Again, we are looking at rotation, counterclockwise or clockwise of 180. It doesn't matter which way we're going when we're looking at 180. Our rule is negative x, negative y. So I'm looking at all my points again. This point P. This one goes to negative x, negative y. I'm not switching them this time. I'm just making both negative. So it'll be negative 2, negative 6. So we will do this with all of our points. All right, so you can see my new points of negative 2, 6, negative 6, negative 5, etc., etc. So now we want to plot those points. We should expect this to rotate 180 degrees and end up in the third quadrant. All right, we did our rotation points correctly and it ended up in our third quadrant. You can see that your shape rotated 180 degrees. Again, let me know whenever you have questions. The independent practice looks like this. You should have also picked this up coming into class.